And some more problems from section 10.1. This is number 25. And again, we want to find for this curve, x equals 2 minus t, and y equals t cubed minus 4t. These are the parametric equations for a curve where we have horizontal tangents and where we have vertical tangents. So again, as in 23, the horizontal tangents are where the numerator would be 0, the fraction, that's dy dt, for the dy dx, I should say. Okay, so again up here, here's our dy dx. And it's going to have a slope of 0 when the top is 0. It's going to be undefined when the bottom is 0. Okay, so what we do is we, again, take these equations. Again, I apologize if my notes are a little bit light. Hopefully you can read these. Right now I just don't have time to redo them in pen. Okay, so we set the derivative of the dy dt equal to 0. So here's y. So if I set that equal to 0, it's going to be 3t squared minus 4. And I set that equal to 0. If I solve for t, I just would add 4 to both sides, divide by 3, and then take the square root, and we would get t equals plus or minus the square root of 4/3. And I can break that up. The square root of 4 is 2, so plus or minus 2 over the square root of 3. So I'm going to put that into both these values to find out the coordinates of my point. So 2 minus t, so 2, and that was plus or minus. So I'm going to have two values, so I have 2 plus or minus 2 over the square root of 3, so I get two values, and I just work these out on my calculator. 2 minus 2 over the square root of 3 is 0.845, and then 2 plus 2 over the square root of 3 is 3.155. So these are my x's, okay, with the plus or the minus, and the same thing with the y's. I put the plus or minus 2 over the square root of 3, I put this in the equation for y. And again, I got two answers because I had plus or minus. So I got either negative when it was positive, negative, I guess I got negative 3.079 and 3.079 for both of these, okay? So it was negative, I had 0.845 and negative 3.079, and then when it was positive, I had 3.155 and 3.079. Okay, so that's what's happening as far as the horizontal tangents, and then if we want to look at the vertical tangents, we just want to make sure that the denominator is 0, so the dx dt is 0. Well, if we take the derivative of x, we're going to get, that's going to be 0, and that's going to be negative 1. So that's the dx dt equals negative 1, but negative 1 is never equal to 0, so nowhere do I have vertical tangents. Okay, so take a look at that. I hope that all makes sense. I hope you can read it. And that's number 25.